everyone. This is Pranshi Verma from ABES Engineering College, Ghaziabad. In this lecture, we will discuss the topic tree map class and hashtable class from Java Collection Framework and subject Object-Oriented Programming with Java, BCS 403. Now, let's get started. The tree map class of the Java Collection Framework provides the tree data structure implementation, and here tree is red, black, tree. Here is the diagram shows the implementation of tree map class. In this, first we have map interface, then we have sorted map interface. This is extended by the map. And then navigable map is extended by the sorted map. And in this, we have tree map class. It's implemented by navigable map. Map class is implements by the navigable map interface. Here are some key characteristics of tree map, and in this first we have sorting. Tree map class maintains its entries sorted order according to the natural order of its keys or by a comparator provided at map creation time. This means that the keys are automatically sorted when inserted into the map. All right, next we have performance. The tree map is implemented as a red-black tree, as I already told you. So red tree is a type of self-balancing binary search tree. This guarantees that the basic operations such as put, get, remove, and contains key has a time complexity of order of log n. So the performance is consistent and predictable due to the balanced nature of the red-black tree. Next, we have null keys and values. Tree map doesn't allow null keys, but it allows null values in it. This contrasts to hash map, which allow one null key and multiple null values. If you attempt to insert a null key, a null pointer exception will be thrown. Now, next we have navigable map interface. Tree map implements a navigable map interface, as I already told you. Navigable map interface provides different methods to navigate the map in terms of key ranges and their order. Next, we have map views. Tree map allows you to create submaps, which are views of a portion of the map. And these views reflect changes made to the original map and vice versa. Let's move forward. Now let's discuss some methods of tree map. Here, tree map class of the Java Collection Framework provides the tree data structure implementation, as you know, and that is red black tree. So here are methods of tree map class. In this, first we have put method. Put of keys and value. This method associates the specified value with the specified key in the map. Next, we have get of object key method. This method returns the value for which the specified key is mapped or null if this map contains no mapping for this particular key. Next, we have remove of object key method. This method removes the mapping for this key from the map if it's present in the specific map. Next, we have size method. As size method returns the number of key value mappings are available are present in the map. And we have clear method. Method removes all of the mappings from the map, and it's all about different methods of tree map. Now it's time to discuss a code implementation of tree map class. Here is the code implementation of tree map class. In this, first we have our package, that is unit4_ctl. Then we just import necessary libraries, and to implement the tree map class, we have required means tree map class required two libraries. First we have .tree map and second we have map from the java.util package. So here we're importing both, that is tree map and map, both the packages from the java.util package. Next we have our class name, that is tree map example, and in this class we have our main method. This is the entry point of our program. Now create tree map class. To implement tree map class, firstly, we're just creating a tree map. As tree map is a class, so we can create object of it directly, and we can create tree map directly without any interface, that is map. So here, first we have our class name tree map and followed by two data types for keys and values, and they are a string and integer respectively. Then we have numbers, that is variable name for our tree map, and then equal to new sign, then equal to sign, and then new keyword, and then your tree map class and generic signature and method signature. In this way, we can create a tree map class in Java collection framework. Next, we have insert elements to the map. So with the put method, we can insert different key value pairs inside the map. So here we are just insert first value, that is key value pairs. First we have apple in 1, then we have banana in 2, and then cherry and 3. Now just print our initial map with the help of numbers variable name. Now next method, if you want to access keys values of the map, so you can use it with the you can do it with the help of dot key set method in tree set class. Next, we have if you want to access values of the map, so you can do it with the help of dot values method with the numbers variable name, as numbers is the variable name for our tree set class. Next, if you want to access entries of the map, entries means key and values together associated with that. So here we can do this task with the help of dot entry set method. Next, we have remove an element from the map. So you can use dot remove method to perform this task. Next, we have if you want to iterating over the map entries, so you can use a for each loop. So firstly, we have map dot entry of a string and integer means it iterates all the key value pairs are available in the map, and then numbers dot entry set. Then, if you want to just print all the iterated values, so you can use system.out.println method, dot get key method, and dot get value method. So access or to access all the keys and values are present in the map. Next, we have accessing the first and last key. So you can do it with the help of dot first key method and dot last key method respectively. Now next, if you wanted to accessing the lower, floor, ceiling, and higher keys are available in your tree set class, so you can use this. So you can use the lower key method, floor key method, ceiling key method, and next one we have higher key method respectively to perform these four tasks. That is accessing the lower, floor, ceiling, and higher keys value in the tree set class. So now it's all about simple code example of tree map class. Now it's time to run the code with the help of run button. See, here is the output of our code. First, we have initial map that contains three key value pairs, that is apple equal to 1, banana equal to 2, and third key value pair is cherry equal to 3. Now, if you want to access only keys, so here all the keys are returned, that is apple, banana, and cherry. Now, values. Values are 1, 2, and 3 respectively. Now, let's check all the entries. So here it returns all the entries are available in your tree set class. Now, if you want to remove value, that is 2. So, entries after removal, that is apple needs to be value key, and Cherry needs to be value 3. Now, if you want to access first key, so here our first key is apple and last key is cherry. Right now, we have only two key value pairs in our tree set class. That is, first we have apple and second we have cherry. So here, lower than cherry, it leads to be returned. It leads to be apple. Now, lower than cherry, it leads to be cherry because there is no key value present in the map after that cherry. And here selling key of banana that is cherry and higher key than banana that is also leads to be cherry. So it's all about output of our code that is tree, set, class, example with code. You can use this code in your examination. Now let's discuss our next class. Next we have hashtable class. Hashtable class. Hashtable class in Java is a part of the Java collection framework and was part of the original version of Java, means initial version of Java. It uses a map interface and is similar to the hash map. Its differences primarily related to thread safety and the handling of null values. Like, like vector, hashtable is also a legacy class and it was available in the original version of Java. Now let's discuss some key characteristics of hash table, and in this first and very main and very important characteristics is thread safety. Hash table is a thread safe because all its methods are synchronized. This means that only one thread can access or modify the hash table at a time. And it's ensuring that concurrent modification don't lead to inconsistent states or data corruption. However, the synchronization can lead to performance bottlenecks in high concurrency scenarios. Now, we have next characteristics is null keys and values. Hash table doesn't allow null keys or value. Attempting to insert a null key or value will result in a null pointer exception. This behavior contrasts with hash map and which allows one null key and multiple null value inside the hash table class. Next we have legacy class. As I already discussed with you, hash table is considered a legacy class. It introduced in the original version in Java, that is 1.0, with the introduction of the Java collection framework in Java 2, that is Java 1.2. Hash map and concurrent hash map has largely replaced hash table for new development. Despite this, hash table is still in use for maintaining backward compatibility in older code base. Next, we have performance. Due to synchronized methods, hash table can be slower than hash map. Single-threaded or read mostly environment. The overhead of acquiring and releasing logs for every method calls add latency. For high concurrency scenarios, we can say that concurrent hash map offers better performance and scalability. We have capacity and load factor. The capacity and load factor determine when the hash table will be rehashed. Rehashed means that is resized. Rehashing occurs when the number of entries exceed the products of the concurrent capacity and load factor. Means the default initial capacity of the hash table is 11 and the default load factor is 0.75. It leads to the load factor represents the maximum ratio of entries to buckets before resizing. So here, initial capacity is 11 and default load factor is 0.75. Now, let's discuss a core example of hashtable class and explore more about it. Here is the code example of hashtable class. In this, first we have our package name that is unit4 underscore CATL and then importing necessary package to create hash table in Java collection framework, and they are hash table and map from java.util package. Next, we have our public class name, that is hash table example. Now it's a default class here, not a public class. And in this, we have our main method. This is the entry point of our Java program. Now it's time to create a hash table with the help of a standard syntax to create any interface, any classes in Java collection framework. So here first we have our class name, that is hash table, and then data type for keys and values. They are a string and integer respectively. Then numbers as an variable name for our hash table. Then equal to sign, new keyword, and followed by class name, generic signature, method signature, and so on. So here, with the help of this line, we are just create a hash table in Java collection framework. Now it's time to insert element to the hash table. So with the help of put method, we can insert key value pairs inside the hash table. So first we have apple and 1, then we have banana and 2, and then cherry and 3. Now if you want to print initial hash table, so you can use system.out.println method, and with the help of numbers, that is variable name for our hash table, we can print all the values are available in our hash table. Now access keys of the hash table. So with the help of dot set method, we can access all the keys are available in the hash table. Next we have how to access the values of hash table. So you can do it with the help of dot values method with the variable name of our hash table, that is numbers. Now, if you want to access entries of the hash table, entries means key and values both. So here you can do it with the help of dot entry set method. Now, if you want to remove an element from the hash table, so you can use it dot remove method and just give the value in the bracket you want to remove it. And then just print the updated hash table with the help of system.out.println method. Now, iterating over the hash table entries. So you can iterate over the hash table entries with the help of for each loop. And in this, first we have map.entry method, and then we have numbers.entry set method to iterate each and every key value pairs are available in the hash table. And then just print all the values with the help of system.out.println method. And here we are using two methods, that is first for dot get key method and second is dot get value method for values, and this method is used to get the keys. Now check if the hash table contains a specific key or not. So you can do it with the help of dot contains key method, and then just print the value, and then just print the statement with the help of system.out.println method. Now check next check if the hash table contains a specific value or not. So we can perform this task with the help of dot contains value method. So it's all about simple code example of hash table. Now it's time to run this code with the help of run button. Here is the output of our code, that is hash table example. In this, first we have our initial hash table that contains the all the key value pairs are available in the hash table. Just note it down here. Hash table doesn't follow any order. Here, it just follow any natural order and gives the key value pairs in any order. Means doesn't follow any order. Here, first we have cherry, then apple, and then banana. Now, access the keys. So here, all the keys are present, that is cherry, apple, and banana. Now, values associated with these keys, and they are 3, 1, 2 respectively. Let's check entries. So here, all entries are given. Cherry equal to 3, then apple equal to 1, then banana equal to 2. Means all key values are returned with the help of entries. Now remove the value, that is 2. And check entries after removal, as values 2 is already removed here. So here it returns only two key value pairs. They are cherry with 3 value, and then our next key is apple and value is 1 associated with this key apple. Logic contains key apple. Yes. Our updated hash table that contains apple here, so it returns true. Logic contains value 3. It returns true because here our cherry key the here and it's associated with the value 3. So here our map, our hash table contains the 3 values in it. So here it returns true. So, so dear students, it's all about hash table example code and their output. You can use this code in your examination with output and their diagram also. At last, we can say that hash table is a thread-safe implementation of a hash table that doesn't allow null keys or values. It's considered a legacy class and has been largely replaced with hash map and concurrent hash map in modern Java development due to performance and flexibility reasons. However, understanding its characteristics remain important for maintaining and working with older Java code bases. For high concurrency needs, concurrent hash map is recommended over hash table. So it's all about hash table. These are the references are used to design this lecture. Thank you so much for your patience listening. In the next lecture, we will discuss the remaining topics of Unit 4 in object-oriented programming with Java. Stay tuned for next lecture. Thank you.